Lesson L023, Building AI Tools and Products. Welcome to Lesson 23, where we shift from understanding AI to building with it. This lesson covers the practical skills and decisions involved in creating AI-powered tools and products. Whether you want to build a simple chatbot, a complex multi-agent system, or a full SaaS product, the principles in this lesson will guide you. We will cover choosing the right AI model, API integration patterns, building user interfaces, deploying and scaling, and monetization strategies. The goal is to give you a practical framework for turning an AI idea into a working product. Let us begin with choosing the right AI model, which is the foundational decision in any AI product. The landscape of available models is vast and growing rapidly. For language tasks, the major options include OpenAI's GPT-4 and GPT-4o, which offer the strongest general reasoning and instruction-following capabilities. Anthropic's Claude models, particularly Claude 3.5 Sonnet, excel at nuanced analysis, long context processing, and code generation. Google's Gemini models offer strong multimodal capabilities and competitive pricing. Meta's Llama models and Mistral's models represent the leading open-source alternatives, offering flexibility for self-hosting and fine-tuning. The choice depends on several factors. Capability is the first consideration. If your product requires complex reasoning, multi-step planning, or nuanced understanding, frontier models like GPT-4 or Claude 3.5 Sonnet are appropriate. If the task is simpler, such as classification, extraction, or straightforward generation, smaller and cheaper models may suffice. Cost is the second consideration. API pricing varies dramatically. GPT-4o costs approximately $5 per million input tokens and $15 per million output tokens. Claude 3.5 Sonnet costs $3 per million input and $15 per million output. Open-source models like Llama can be self-hosted, eliminating per-token costs but introducing infrastructure costs. For a product processing 10 million tokens per day, the difference between a $3 and a $15 per million token model is over $360,000 per year. Latency is the third consideration. Larger models are slower. For real-time applications like customer support chatbots, response time matters. Smaller models or distilled versions can provide faster responses with acceptable quality trade-offs. Privacy and compliance are additional factors. If your product handles sensitive data, self-hosted models or providers with strong data protection guarantees may be required regardless of capability differences. API integration patterns determine how your product communicates with AI models. The simplest pattern is direct API calls, where your application sends a request to the model's API and receives a response. This works for straightforward use cases but becomes complex when you need to manage conversation history, handle rate limits, implement retries, or chain multiple model calls together. The most common advanced pattern is Retrieval Augmented Generation, or RAG. RAG combines a language model with a vector database containing your domain-specific information. When a user asks a question, the system first retrieves relevant documents from the vector database, then includes those documents in the prompt to the language model, which generates an answer grounded in your data. This approach addresses one of the fundamental limitations of language models: they only know what was in their training data. RAG allows your product to provide accurate, up-to-date information from your specific knowledge base. Building a RAG system involves several components. The embedding model converts your documents into vector representations. Popular choices include OpenAI's Text Embedding 3 Small, Cohere's Embed v3, and open-source models like BGE. The vector database stores and retrieves these embeddings. Options include Pinecone, Weaviate, ChromaDB, and Vector. The language model generates the final response using the retrieved context. The quality of a RAG system depends heavily on chunking strategy, which determines how documents are split into retrievable pieces, retrieval quality, which determines whether the right documents are found, and prompt engineering, which determines how the model uses the retrieved information. Multi-agent systems represent a more sophisticated pattern where multiple specialized AI agents collaborate to solve complex tasks. Each agent has a specific role such as research, analysis, writing, or coding, and agents communicate with each other to accomplish goals that no single agent could handle alone. Frameworks like Crew AI, LangGraph, and AutoGen provide infrastructure for building multi-agent systems. The key challenge is orchestration, determining when agents should communicate, how to manage shared state, and how to handle failures in individual agents without breaking the entire system. Building user interfaces for AI products requires thoughtful design decisions. The conversational interface, inspired by ChatGPT, is the most common pattern. It works well for open-ended interaction but can be frustrating for users who have specific goals and need guidance. Effective conversational interfaces provide suggested prompts, example use cases, and feedback mechanisms that help users discover what the AI can do. Task-specific interfaces are often more effective than general chat for defined use cases. Instead of asking users to figure out what to type, these interfaces provide structured inputs, templates, and workflows. An AI-powered email composer might offer fields for recipient, tone, purpose, and key points, rather than expecting users to describe their email in a text box. The output is still AI-generated, but the interface guides the user toward better results. Real-time feedback is important for AI interfaces. Unlike traditional software where the response to a user action is immediate and predictable, AI responses take time and vary in quality. Streaming responses, where text appears word by word as the model generates it, keep users engaged and give them early feedback on whether the response is on track. Loading states, progress indicators, and the ability to regenerate or edit responses improve the user experience significantly. Error handling in AI interfaces is different from traditional software. AI models sometimes produce incorrect, biased, or inappropriate outputs. Your interface needs to handle these gracefully, providing users with the ability to report issues, regenerate responses, and understand the limitations of the system. Clear disclosure that the user is interacting with AI, not a human, is both an ethical requirement and a legal requirement in many jurisdictions. Deploying and scaling AI products presents unique infrastructure challenges. API-based deployment, where your product calls external model APIs, is the simplest to deploy but introduces dependency on external providers. Rate limits, API downtime, and pricing changes are all risks. Building abstraction layers that allow switching between providers mitigates some of this risk. Self-hosted deployment, where you run models on your own infrastructure, provides full control but requires significant investment in GPU hardware and infrastructure expertise. Cloud GPU providers like AWS, Google Cloud, and Lambda Labs offer on-demand GPU instances that make self-hosting more accessible. The cost structure is different from API pricing. Self-hosting has high fixed costs for hardware but low marginal costs per inference, making it cost-effective at scale. Latency optimization is critical for user-facing products. Techniques include model quantization, which reduces model size and increases inference speed at the cost of slight quality reduction. Caching common queries eliminates redundant API calls for repeated requests. Prompt optimization, reducing the length of prompts while maintaining quality, decreases both latency and cost. Content delivery networks and edge computing can reduce geographic latency for global users. Monitoring and observability are essential at scale. Track metrics including latency, throughput, error rates, token usage, and cost per request. Set up alerts for anomalies such as sudden increases in error rates or unexpected spikes in API costs. User feedback mechanisms, including thumbs up and thumbs down ratings on AI responses, provide qualitative data on model performance. Monetization strategies for AI products follow patterns from software as a service but with additional considerations. Subscription pricing is the most common model. Offer tiered plans based on usage limits, features, or model access. A free tier with limited usage attracts users and demonstrates value. The key challenge is setting usage limits that encourage upgrade without frustrating free users. Usage-based pricing charges per token, per request, or per generation. This model aligns costs with value delivered and avoids the problem of light users subsidizing heavy users. However, it introduces unpredictability for customers and requires careful monitoring to ensure unit economics work. The cost of AI inference must be factored into pricing. If a GPT-4 call costs your product 5 cents and you charge 10 cents per request, the margin looks healthy. But if heavy users generate hundreds of requests daily, the aggregate cost can be significant. Many AI startups have discovered that inference costs can consume 50 to 80% of revenue if pricing is not carefully calibrated. The freemium model is particularly effective for AI products because the technology is still novel and users need hands-on experience to understand the value. Offering a generous free tier with clear upgrade incentives converts users who have experienced the product's value firsthand. Enterprise sales for B2B AI products often require custom pricing, dedicated support, and integration assistance. Enterprise customers value reliability, security, compliance, and support over raw cost. Building an enterprise-ready product requires SOC 2 compliance, data processing agreements, dedicated infrastructure options, and professional services capabilities. As we conclude this lesson, building AI tools and products is more accessible than ever thanks to powerful APIs, open-source models, and cloud infrastructure. The barrier to entry has dropped dramatically, but success still requires careful attention to model selection, architecture, user experience, and business model. The most successful AI products are not the ones with the most advanced technology. They are the ones that solve real problems for real users with a sustainable business model that supports ongoing development and improvement.